Hello, this is Valentin Mihov from Team 62, and this is my Viva for the Robotics programming module. Our algorithm uses the first search and Floyd's algorithm in order to complete both tasks. Assuming the given maze, it is assumable that we're operating on a 16 by 16 cost matrix and given cost of each node, starting from 0 to 15, not including the starting position. Then, using depth first search to visit each node and using Floyd's algorithm to store the shortest path from 0 to 15 in phase 2. So the first step in phase 2 is going forward. We have a function going forward in order to enter the maze to 0. For every square in the matrix, variable memory that indicates visited or not is allocated. For the first part, we go to every square, which includes all the corners, so this satisfies our first task. Then the robot uses getPath to return to starting position, which is square 0, and afterwards it goes to starting position, turns around, and indicates that it's ready for the second part. So throughout the first part, it scans for the current and next node by using current to next function. So for the second part, it uses the map that has been created from the first one, and it uses the Floyd's algorithm in order to complete it. So throughout it, a function called adjusting phase is also used. That makes the robot go up the vertical axis of the matrix. It uses the previous degrees of turning in order to indicate its orientation. It is used only when there is a path that will take it up the matrix. For example, if we're at position 5, it will turn around to go to 9 and 13 if possible only. So for a 4x4 map, it starts from the bottom left corner. If 1 is on the x square, for example, x plus 4 goes up, x minus 4 goes bottom, x plus 1 goes right, and minus 1 goes left. So in order to complete the task, as I mentioned, we're using Floyd algorithm to go to number 15, which is the diagonal from the starting position. So we're using the minimum distance, the Floyd algorithm. So in order to go from I to j, for example from 0 to 15, we consider if ik plus kj is less than ij, it takes up the minimum distance, else it takes up the ij path.